But with that one, I would like to welcome on stage Emily Bache. And before I let her take over, and before I take this one out, I've been in multiple Europythons in the past. I've seen Emily speaking. So she has her bio of being really good. And if you have ever checked anything done by her, she's really good at advocating test automation, general software development practices, and anything around that. But I've seen her 2 talks, one in Birmingham and one in Berlin, which have been amazing. And I'm really, really looking forward from hearing from her today in here. So let's give her a big hand and welcome her on the stage.
So I was so pleased to be invited to PyCon Sweden. It's great to be here. Now, my computer has just decided to go to sleep and not wake up. Oh, there we are. Here we are. Great. So let me just put my slides up. So I'm very pleased to be speaking to you about this topic, about development culture and helping the business to win. So this is a topic I chose because I think we're at a very important time right now in the software industry. I found this little video. No, isn't it going to show me the video? I want to show the video. It's not working, right? This is not what you want in your keynote when you're trying to inspire people. And my mouse is not going onto the screen. There we are. I'm trying to show it. So this video here, some Harvard researchers put together this video about how our desk has changed since the 1980s until more recently. And basically more and more of the stuff that we do, the work we do, is moving into the computer. It's moving into software. And the rate at which things are disappearing from our desk is just kind of accelerating. Here we are, everything we do now is centered around the computer. We've got all this software that does all this stuff, and what we remain with is a computer, a phone, and some sunglasses. So I just thought that really kind of summed up where we're at, and the pace of change is just increasing. So I found that kind of a cool thing. And software is eating the world. This is an essay from Mark Andreessen from 2011, which has got a lot of attention. Because, 2011 isn't that long ago. But he basically says that, after 6 decades of the computer revolution, 4 decades since the invention of the microprocessor, 2 decades into the rise of the modern internet, all the technology required to transform industries through software finally works and can be widely delivered at global scale. He's saying, basically, that now we're at the time in history where computers and software can take over all industries. This is going to be the future. Every industry needs to look at how it's going to be disrupted by software. And we, as software developers, I think, are in a really good position in our modern world to change the whole society we live in. So I think we need to be good at our jobs, because this is really important. I think it's also a really exciting time for Python developers. So I joined the Python community back in 1999, actually. I did an online course learning Python and all the little examples from the Monty Python series, programming spam and such like. And I found that this was, I really like the language, I like the community. And I think it's been growing and the language has been improving for many years now. But it's only in the past few years, actually, it seems to be really taking off. I've been running the Python user group in Gothenburg since nearly 10 years ago. And the Python user group has never been bigger and has never had more people at the meetings than we're having at the moment. It seems to me that Python is really that language of the time. And it's very exciting to be part of this community right now. So I think this is an important time for software, an important time for Python. And I would like to look at how what we do as software developers, the way we organize ourselves to write code and what we do during the day, how that can contribute to the success of the businesses and the organizations that we work in. So I have some anecdotes from my own career about the kind of what I mean when I say development culture. So I wanted to talk about some experiences I had where a few years ago I was working in an organization which had a very strong culture of pair programming, writing automated tests for all production code, daily contact with users. It was a really fun environment to work in. And I found that we were writing very good software, in my opinion. The thing is, that project was ultimately not successful. The customer canned the project, and we all had to find something else to do. In fact, that was the second time that had happened to me. I worked in another organization previously that also was really, really good technically. We had excellent pair programming and testing and all that. But again, it was cancelled. So that in my own experience, that really, really productive developer culture didn't lead to business success. Then I have another anecdote which I like to tell. This is an experience I had a few years ago when I was visiting my cousin in Canada. And I wanted to borrow his car, and he very kindly offered that I could borrow it. And I must have looked a little bit nervous when he handed me the keys to his car, because he said to me, he said, "Oh, really, don't worry. I just want to reassure you, really don't worry about my car. I mean, in fact, you could do me a favor here. If you crash my car, then, just make sure you crash it properly, because then I can get a new one, So he was being very reassuring to me, and of course I didn't crash his car, so it was fine. But then I was reminded of this just a couple of weeks later when I was back at work, because I was working on this software and I had to make some changes in a piece of software where the company culture and the company policy at that time was that I had to ask permission from the architect who owned this piece of code. So I must have been looking a little nervous when he handed me back my UML diagrams, because he said, "Don't worry. You seem very concerned about the quality of this code and improving the design, and really, you could actually do me a favor here. In fact, it would be much better if the design of this code got worse, because the sooner this code becomes legacy code, the sooner I can rewrite it." So this kind of attitude in the developers department that the best code is the code that you rewrite from scratch, and actually what we really want is for our code to end up like this car, kind of completely stuck in a ball of mud, unable to move. And that this is the culture that was there, and I really didn't get on with that organization. And I left not long afterwards. But the thing is, that was a very successful business with a very successful software, and it didn't match up for me. This happens kind of similarly to me again more recently when I'm working in an organization with a branching model, which I found utterly bewildering that this could possibly work. I mean, there is lots of different ways of doing branching in your software. And you may be familiar with the idea of feature branches, where every time you have to work on a new feature, you pull out a new branch and you start developing your feature, and then you submit a pull request to your colleague at the next desk, who then has to review your code and approve it and merge it in. The thing is, this organization was doing all that, but not just with feature branches, because the usual thing is you merge your feature branch back into master. This organization had epic branches. So you're merging all your features into these epic branches, which are epic and live for an entire half a year or something. And only after it's been reviewed by the senior architects and so on can it actually be merged back to master. So you get a really awesome merge conflict at that point. And you have to do some really hardcore debugging, and then you get a wicked release like a boss, I'm like, how can this possibly work? And it kind of is working for them, but I'm just like, that's not a good way to develop software. The best software organizations I've seen are working on trunk or master, as it's called more usually. So that experience puzzled me, because this was a very successful organization too. And And then I had another anecdote, and this is more where things actually lined up for me. This was an organization doing drug discovery, and I worked there for quite a while, actually. And we're doing predictive drug discovery in very, very early stage drug development. And I decided that the best thing was if we could sit as close to our users as possible. So we had daily contact with the scientists, the chemists, who were developing the software with us. And they were producing models with neural networks and machine learning techniques, and we were integrating them into this piece of software that we were delivering to thousands of scientists internal to that organization. This is 10 to 15 years ago. This is a while back, and that system was all built in Python. And we had a really good time, and that system was very successful. So sometimes it does work out. The test automation that we put in place, the collaboration with the users, that little robot there is test automation, by the way. So it's all kind of worked out in that case. But so this is what I mean when I talk about development culture. This is how do we do code reviews? Do we do pair programming? Do we do pull requests? How is our branching model? How do we decide about feature branches and so on? What is our attitude to legacy code and design? Do we have a good idea about how to build good quality code? Do we have good collaboration with our users and other professionals who we need to get the software going, and do we have automation and test automation in particular? That's kind of my speciality. So all of this is what I would include in developer culture, and this is what we do daily. This is the way we build software as developers. And it really interests me to see how does that relate then to the success of the business, because in my career, just the experiences I've had over nearly 20 years, it's not always clear that the best development culture leads to the most business success. So I was kind of looking around and, well, let's look at some successful organizations. What kind of culture do they have? And I found this example that really fascinated me. Apple. Apple is a really, really successful organization that builds software. And this is an extremely famous bug. I don't know if you've seen this line of code here. This is C, and in C, indentation is not significant. Mistake there, I feel. So this means that this piece of code is always executed, despite it looking like it should be included in this indented block. And what this does means that when you get to that line of code, it just jumps. It's like raising an exception, this goto. It jumps out and does something else. So all of the checks that come after that are never executed, which means that your secure socket layer actually isn't so secure. This was 2014, and it affected lots of Apple products and was very embarrassing for Apple, that when you're surfing on your phone, this is what it means. This is like SSH connections weren't trustworthy. Because normally with SSH, you can go to your bank and be secure that you're talking to your bank. And if you're not, then you get this like warning thing from your browser saying, no, there's a problem here with the SSH and the certificate. And so what this bug meant was that in Apple products, you could think you were talking to your bank securely and you weren't, So this is a pretty serious thing. And it received a lot of attention. And because this code was open source, we could go in and have a look at it, see this bug in context. So a lot of people were saying, this should have been found in code review, this should have been found by unit test. And you're like, well, why wasn't it? Well, what I did is I took the source file that contained this bug. It's a 2,000-line file. And I printed it in 4-point font in 3 columns, and it still took 7 A4 pages. I was hoping to get it on a slide, but I had to content myself with just 2 of those 7 pages. And I've just highlighted here, if you see the yellow bits, that is the 6 places in the file where that algorithm is duplicated. Those checks for SSH security are duplicated 6 times in this file. So you can kind of understand why they didn't find this bug with code review. They didn't find this bug with unit test. There's no units. There's nothing here you can actually pull out and unit test. And I read a very critical essay of this, and this is on Martin Fowler's blog, where he says, The presence of 6 separate copies of the same algorithm clearly indicates that this bug was not due to a one-time program error. This is a pattern. This is evidence of a development culture that tolerates duplicated, untested code. That's a pretty harsh assessment, and I think it's fair in this case. That is really not the way you want your code to look, and it's a product of the culture of the developers who are working on it. So clearly, if you get the culture wrong, things can go badly wrong. Yet Apple is still successful. So let's look at some more positive examples. I read this example from Tesla. So I don't know if you've seen this, but this is from 2016. Somebody, a random Tesla owner, tweets to Elon Musk, the CEO of Tesla, my San Mateo supercharger is always full with idiots who leave their Tesla for hours even if it's already charged. So Elon Musk tweets right back and says, okay, you're right, this is becoming an issue. Supercharger spots are meant for charging, not parking. We'll take action. So a master use of Twitter there, masterful. But he not only, follows up with his customer complaint, Tesla delivers. 6 days later, they roll out an update to all of their fleet of cars that solves this problem. Suddenly, if you're parked at a charging spot and your car is fully charged, you get charged 40 cents a minute. Problem solved. People stopped using these charging spots as parking spaces. So this is kind of really impressive. Just 6 days, and they've got a new feature out, and they've rolled it out to cars. Cars! This is an industry you wouldn't expect to be able to do that. But so this is. There's been some commentary. I think they probably were developing this feature a little bit before this tweet exchange. They probably had it on their list in some level. But still, it's very impressive that they managed to get this out. And then there's another example which I really like, where there's this satellite in space. It's supposed to be docking with the International Space Station. And the Orbital Sciences company who've put this satellite up and launched it into orbit, unfortunately there was a glitch in the software and it couldn't dock with the ISS. So it's hanging there in orbit. And they announce, actually I think we can patch this. We can solve this software problem. So they do. They send a software update into orbit, and this satellite, a week later, successfully docks with a space station. How cool is that? So you can get your software updates into space. And that is clearly going to be an advantage for those companies who can achieve that kind of response time, who have a developer culture that can achieve that kind of result. That's got to be good. So this is kind of an idea that's been going around for a while in our industry now about agility, about this ability to put out changes when you want to, often, in shorter timescales. This should be related to the way you organize your software development. You want to avoid those bugs. You want to get that software out more often. So I first discovered extreme programming in about 2000, and this is an idea that Kent Beck wrote this book about. Embrace change. We're going to accept changes in requirements even late in the process. This was revolutionary for the time. And the 12 practices of XP are all about developer culture. They're all about these things I was talking about. It's how we organize pair programming and testing, and how we do design to avoid legacy code, and a bunch of other stuff. And I was really excited about this when it first came out. But reflecting on this now, I realized that this whole extreme programming is based around the experiences of Kent Beck and others, people like Martin Fowler and Ron Jeffries, who he worked with on this one project called the C3 project. And they had a great time doing extreme programming. And they thought that they would write this book about it because it was such a good way to work. But actually, arguably, that C3 project wasn't all that successful. So it seems again that these new ideas about how to do development are based on anecdote and experience. And in my experience, they work really well, but do they lead to success? Of course, extreme programming then got followed up by Agile, the Agile Software Development Manifesto, which came out in 2001. And this was now 17 people's experience this was based on. This was a group of people who had long experience in the industry, had worked in a lot of organizations. And this is their best advice about a best way to build software to attain this kind of agility that we want. We want to be able to release software often. And they're stressing again how the developers should work, that you should be interacting with your users, you should be emphasizing working software and tests and this kind of thing. And this, again, was revolutionary and has changed the way we build software across the industry. And this is, I think, quite clear that the idea here is that if we have well-organized development, with good culture, we can be agile and we can deliver more often. We can get features out, we can get throughput. And of course, we can get quality. That's the promise. So the idea is that if you then become agile and get these features out often, then you can make more money. So that's the kind of the promise of agile, and I think it's largely based on experience. Of experienced software developers saying what's worked for them. And there has been some research over the years into Agile and how well it works. But I haven't really seen anything that directly connects the development culture with the money making. I've seen it connecting what the developers do with how agile are you, but that kind of connection all the way was eluding me. So that's what I'm really interested in. How can we make that connection between what we as developers do and how successful the businesses that we work in are? And I was reminded of the debate that's gone on in healthcare. There's been a lot of evidence gathered over the years that if you have lower cholesterol, you're less likely to have a heart attack or a stroke. And then more recently, they discovered this medicine, statins, that would lower cholesterol. And they did lots of studies and discovered that this was a real effect, that taking statins lowers your cholesterol. But there was still quite a lot of debate in the medical community about, well, does that actually mean that taking statins mean you get fewer heart attacks? And I believe that there was quite a debate for a while about whether it was wise for doctors to go ahead and prescribe statins when they do have side effects. And was it actually proven that it was not only going to lower cholesterol, but was it also going to prevent heart attacks? Now, I believe that this debate is largely settled now. I found this article in The Lancet basically saying, yes, there's lots of evidence, there's lots of studies now that show that this is a real effect, that if your doctor asks you to take statins, you probably should, because they probably are basing that decision on good evidence. Trust your doctor. I think the medical community has been doing evidence-based medicine for a long time, and they know how to do it. But I'm looking at software and wondering, where is the evidence for this, you know? This is, we've been building software for quite a while now. Where's the evidence that the way you build software actually affects whether your business is successful? So this is partly why I was so excited when I saw this report. I first saw it in 2014, this State of DevOps report. Because one of the claims that this report makes is that firms with high-performing IT organizations were twice as likely to exceed their profitability, market share, and productivity goals. So this is actually starting to try and link what we do as developers with how successful the business is, and trying to actually do evidence-based statistics on this. It's not double-blind controlled trials published in peer-reviewed journals. It's not quite at the level of evidence-based medicine, but this really intrigued me. What are they doing here? What kind of data are they basing this claim on? So they've been doing this survey every year now. Actually, the first one was 2013. I saw it first in 2014. And it's a survey of practitioners, people in the industry, thousands of people, answering questions which the survey designers have designed to test their hypotheses about DevOps, and I'll talk more about what DevOps is shortly. So then they publish the analysis of this survey in this report every year, and then the researchers also publish follow-on research in peer-reviewed journals. The people behind this report are Puppet and Dora. Puppet is an organization that has a tool that's used often for DevOps. It's a kind of a deployment tool. And then Dora is a newer addition to the team. They are basically consultants selling consulting around this, who will go into your organization and help you to apply the research in your organization. So that's who is behind it and what it is. And I find this really interesting, that what they found through these studies done by professional statisticians who publish some results in peer-reviewed journals, this seems like they might have found out some things that are actually more generally true than just the kind of anecdote and personal experience that we often based our development decisions on. So what they found is that you can measure IT performance with these 4 metrics and then correlate that with organizational success. So the 4 metrics that they have found are basically, firstly, throughput, and secondly, stability. And throughput is, well, how frequently can you deploy changes into your production environment? How fast does it go from a developer committing a change to that change coming out in production? And then stability, how quickly can you recover from downtime? If you have a system go down, there's a bug, there's a problem, how quickly can you get it back up to full service? And then how many changes are succeeding and failing? So when you roll out a new change in production, maybe that's a new version of your software, maybe that's just a configuration change on your server. How often does that succeed or fail? How often does it need to be rolled back or hot-fixed, basically? So this is basically measuring effectiveness, development. How good is your development organization? And how good is your operations? Hence the word DevOps. This is a shortening of development and operations. So this is very exciting, of course, for an organization that's designed to study DevOps, that they've actually found a correlation between organizations that are good at development and operations and the profitability. That seems quite an interesting result. So let's just look back a little bit about where this DevOps thing came from. And it comes from the observation. Originally, they observed that the software development organization was in its own little silo, separated from the operations organization. And often there's even another silo for the product management, the people deciding what product to build. And the thing is, the software development organization is incentivized to make more frequent releases. They're being measured by feature counts. They need to get stuff out. They need to be frequently being agile, producing new features. The trouble is, the operations department is often incentivized and measured on uptime and stability. So they want less frequent releases. They don't want these changes coming in from software development will reduce the stability. They often have bugs. It often causes rollbacks and hotfixes. They don't want that. So it creates this tension because, of course, product management want both. They, of course, want lots of new features and no downtime. So it seems that these 3, if you keep these 3 things separate, none of them can really win without one of the others losing. So product management really doesn't want to make this trade-off. They want both. But it seems set up that way often in organizations. And these DevOps people were trying to say, look, we can't go on like this. We can't keep trading off throughput versus stability. We need to try and find a way to do both. And that's what it turns out. The high performers in these DevOps reports, the people who are doing this well, can achieve good results in both parts, both development and operations. And this really reminds me of the American car industry. Now, this is a graph of market share from like the 1960s until quite recently. So you can see the market share of car sales for the American companies, GM and Ford, is declining, and the market share of these, particularly these Japanese companies, particularly kind of starting in the 80s, the Japanese companies are really taking over the market share in quite a dramatic way, actually. And of course, GM and Ford were quite worried about these Japanese imports, and they thought, oh, there must be a problem here with the dollar-yen exchange rate, or there must be some issue of trade barriers or government subsidies, or, there's something going on here that the American government should fix, We should have trade barriers or something. And actually, it wasn't that at all. The Japanese people in Toyota had developed lean production, what we now call lean production, the Toyota way. They'd found a way to build cars both at a lower cost and a higher quality than the American counterparts. And this revolutionized the car industry. I hope you're all familiar with this. Lean production is the universal way now to build cars, because they managed to solve this fundamental problem. They have both lower costs and higher quality. And that's exactly what DevOps is promising you today, that you don't have to make this trade-off between throughput and stability. You can have both. There are various ways of achieving this collaboration, and that's what this whole report is trying to study. What is the best way to collaborate so that we can achieve this result? And it's clear that some organizations really have achieved this. In the report, they say, this year, they said, as in previous years, we have found that high performers do significantly better than lower performing peers in terms of throughput and stability. In 2017, we found the high performers have 46 times more frequent code deployments, 440 times faster lead time from commit to deploy, 96 times faster mean time to recover from downtime, and 5 times lower change failure rate. Now, that is quite a stark difference. If you realize that is what lean production did for the car manufacturers. Today, all car manufacturers are doing lean production. And I think with these kind of numbers, it can't be very many years before all software organizations have to be doing this. Otherwise, they're just going to be totally outcompeted. This has got to be the future for our industry, if this study is right. So let's dig into this a bit. What are these high performers doing? What are they doing differently that the low performers are not doing? And of course, the statistics is there. They've done this analysis, and in the report they've got this diagram. Now, this is quite a complex diagram. I'm not going to go through all of it, but on the right, I've got a pointer here. On the right here, we've got organizational performance, and they're also looking at non-profits. This is not just for-profit enterprises. But they find that the performance is correlated with the performance of the IT department. That's the first step. It does actually matter how we build software for the performance of the organization if you look statistically at enough organizations. So then, what's driving the IT performance? And they found these 3 things. They found transformational leadership, continuous delivery, and lean product management. Those are the 3 areas that they find the high performers are doing differently from the low performers. And since we're software developers here, I really just want to zoom in on the continuous delivery part. I'm sure that those other parts are just as important, but really the part that interests me is the developer culture. How should we be building the software kind of at the code level? And this is where we get continuous delivery. So I've taken out some of those factors, and just so I can focus on this part. And it seems to me what they've done here is really important for us as software developers, because they've basically given us a way to move the business. This is like a lever for us to change the way we work in order to improve results for the business. There's this old Greek guy who came up with this quote that he discovered the principles of levers and pivots, and he could now move the earth. He knew how to do it. And I think this is a bit like us, as software developers, we now have the lever, the things that we can do in our developer culture that are going to enable us to achieve this change in organizational performance. This is the lever we can use to move the business in the right direction. And what's going to help us, what this is over on this side, this is DevOps culture. This is a development culture of DevOps. So let's talk a little bit more about what that is. So these 6 practices or features of these high-performing teams, I'll start at the bottom. So the first thing is that the development team is empowered. They don't depend on other teams to complete their work. This is the classic cross-functional team. You're including everyone on the team who you need to achieve the result. So for me, that when I was working in the pharmaceuticals business, that was including the chemists on the team, sitting close to them, collaborating with them. This is including those operations people on your team so that you can include the uptime and the maintenance of your servers in what you're concerning yourself about as a software developer. This is clearly an important aspect of developer culture, that it should be inclusive of other disciplines in your team, because you need them. If you need them to get your work done, to complete your work, then you need them on your team, to regard them as people that you rely on. The next one up here is the loosely coupled architecture, easy to modify or replace the different parts. This is, it's talking about architecture here, which is kind of like the biggest pieces of your software, but I think it's you can think about this also at the smallest levels of the pieces of software. Avoiding that legacy code where your code is just a big ball of mud that you can't change. You're trying to get to the point where it's all little pieces that you can exchange and rely on each other in a well-designed manner. Then the other ones up here, I'm going from the bottom here. Shifting left on security, that's including information security as a first-class citizen in the development process. Information security has just become so much more important these days with all the hackers and Russian interference and goodness knows what. This is a first-class citizen now in development. We have to think about security and not letting our data escape or be stolen, or our system to be taken over by outsiders. This is actually very important. So that's something that clearly is being shown in this trunk-based development. Now that's kind of what I was going on here about the feature branches. This kind of indicates me that the successful organizations are not having long-lived feature branches. They're really committing to master like daily. That seems to be the cutoff point. If you're not merging all your code into the master branch daily, then you're not there. You're not going to achieve, statistically, you're not going to achieve this really high performance. Continuous integration is a practice that came from extreme programming. It's about having frequent commits, all the developers committing frequently, getting their stuff into master. And then the first one I haven't explained further because I think it explains itself. Test automation. I think I might have mentioned that earlier. This is a really important part of your culture. And deployment automation too. How you roll out your software in production. But as they say in the report, test automation is the biggest contributor of these 4. So I knew it. Test automation is really important to get right in your software development. I've written a book about learning test-driven development, so it's one of my things that I go on about. So basically, what we've got to at this point, if I could take a few liberties here, is that basically test automation leads to a DevOps culture, which leads to wins for the business. Okay, so maybe I simplify slightly at this point, but I think this is where we need to be thinking about things, that actually test automation is really important. So I've got this other slide here, which is the non-oversimplified version of the same sequence. This is a picture from a paper that was published in a peer-reviewed journal. And it's for statisticians, so it's got like all the R numbers and the correlations of how the different things match up. But as you can see, the test automation there is correlating with organization performance there on the right, and it's got one of the highest numbers. That means it's the most important, I think, speaking as a non-statistician. But the paper also says, in plain text that I can understand, the research suggests that version control, test automation, and continuous integration are the most important aspects to implement in the field. So there you are. The researchers agree with me. Test automation. So this is bringing me basically to my conclusion. This stuff is not easy. Changing your development culture to be like this is not easy. What I'm trying to tell you is it's worth it. Based not on my own experience of anecdotes, not based on the experience of really important gurus in the industry. This is based on research done by researchers in thousands of organizations. Then it starts to become statistically significant. It's possibly not as reliable as the research that would lead you to take statins or not, but I think it's definitely a step in the right direction. So just to conclude, I've talked about my own experience of different kinds of development culture and the fact that I couldn't see a really good correlation between the organizations that seem to be doing development well and the successful organizations. I don't have enough years of experience. We've talked about bugs, how destructive that can be to your organization to have a bug, but yet Apple has managed to have a really serious bug and still be a very successful organization. I don't think you can draw huge, long-going conclusions, basically, from your own experience or from the experience of just a few organizations. We need to start looking broader than that and looking at statistics and more organizations. Which is why I'm so excited about this State of DevOps report, because they seem to be trying to do that, actually base their advice on real evidence, and giving us as developers this lever to try and move the business in the right direction and give us backup and arguments to say, this is the best way to work, actually. We should be writing tests. We should be doing committing frequently and integrating often. And we should be avoiding legacy code, and we should be collaborating with people in other disciplines and getting them into our team so that we can achieve the results for the business that we're being asked to do. So thank you so much for listening to me for this time. I'd like to open for questions. So there's a guy at the back.
What about the Apple case? Can that be how they are so successful? Can that be explained with this model? Or is it just there's a outstanding algorithm?
Yeah, I think they're just basically an outlier. They are so outstanding with their design and the usability stuff that people forgive them, that they can't talk to their bank securely. But yeah, so like I say, I had previous versions of this talk. I tried to look at Facebook and Google and other really successful organizations. What is their developer culture? And I think it's very hard to draw any conclusions basically from these unicorn organizations. The organization you work in probably isn't anything like them. And that's why I'm really pleased to see this, looking at a wider range of organizations to try and decide how is the best way to build software. Yeah? Another question over here?
Yes, so test automation is very important. How do you approach that in your company?
Test automation is very important. How do I approach that? So these days I'm a consultant advising people about test automation. So I will help companies to put together a strategy and help with training, test-driven development and stuff. So what I advise, though, depends a lot on the specifics of the organization's architecture. Unit tests, I think, are useful for everyone. Everyone has units in their software. I think full-stack tests from, end-to-end, the entire thing. They're normally useful, but you only need a few of those. What you need in the middle, I think, depends on your architecture. And I'd be very happy to advise you on that for a fee.
You mentioned that you've had good experiences with pair programming. And I was wondering, do you think that somehow fits into this research, into this model of what constitutes successful DevOps? Or is that just something you enjoy?
Okay, so the question is, pair programming, is that a success factor or is that just something I enjoy? Well, it doesn't actually come up explicitly in their reports, actually, as one of the practices that's highly correlated. What does come up is code review. That's definitely correlated with success. But I don't think it's specifically... so, I don't know, this is a question I'm quite interested in, because there's definitely a correlation between organizations who do code review and who are successful. And there's a correlation between organizations with a short lead time from commit, no long-lived feature branches, and success. So it seems to me that if you're doing pair programming, then that's going to give you the shortest lead time from commits to getting it into master. If you put the code review after the development is done and you have a pull request process, that's going to delay the integration of that change. And so it seems to me that although the research doesn't explicitly say it, that pair programming ought to be superior to pull request review. But they don't mention that explicitly in the report, but that's my opinion at the moment.
Talking about things that lead to fewer heart attacks, do you think that maybe a good development culture actually leads to more heart attacks?
Because does a development culture lead to more heart attacks? Sorry, why?
It's kind of stressful. It may not necessarily be the most pleasant and fun way for that person to work. It's not necessarily the most effective.
Right. So the effective developer practices might not be a fun way to work. So I think this research discredits that idea. I think there was a strong correlation actually between, I think it's on this slide, the organizational culture is strongly correlated with IT performance, and the biggest factor in organizational culture that's correlating there is job satisfaction, actually. So the high-performing organizations also have the developers with the highest job satisfaction. Just having read this research in a bit more detail, I think that's true. So, yeah, I don't think that theory stands up. I think you can have fun at work and be a high performer. Okay?
I come from the pharmaceutical side, and here you have a little bit, for a long time, the slogan, rather quality by design, rather than quality by testing at the end. And maybe there are many aspects of test automation, but I mean, the key is not just to test at the end, but very early.
Yeah, so the question is about test automation and whether, testing at the end, can that really produce quality in the system? And I agree with you, that's probably a fallacy. You need to build quality in from the start. And the testing efforts and the test automation efforts need to start at the same time as the software development efforts. So that's why I'm a strong proponent of test-driven development, that you write the tests in advance of the code, or at least at the same time, checked in the same commit. So I think you're right. Test automation doesn't just mean taking a bunch of manual tests at the end of the process and automating them. That's not really what I'm talking about. Yeah? There's another question here.
Yeah, it seems that this only applies when you have pieces that have competition. You take government contracts.
Government contracts. Yes, so
Because there will be some political or upper decision maker that will go with, oh, this low price per hour, just like that. And then the product will have no competition.
right, so the problem of governments is there's no competition and they can produce really awful software and everyone has to use it. So that they've got no incentive to improve the way they work. Well, it's funny you should say that, because I was just listening to a talk by one of the main DevOps proponents, and he's just been involved in a project at the US government implementing DevOps practices to make the US government more efficient. And so I don't know quite how the full details of this, but he relates that he received a letter from, I think it was the US Navy, thanking him for his work and say that you've just reduced our costs for producing a new piece of software for the Navy by some staggering amount of money, which I can't remember. And we're so grateful to you. So I think even governments are cost aware, and if you do DevOps right, it will reduce your costs, not just produce better results. So I think there are arguments for doing this even in government, and people are doing this, DevOps, in government.
Yeah, I think of course there are arguments, but how do you get those across to those decisions?
Oh, right. So that's I think that's politics. Yeah, it's a bigger problem. How do you persuade a company that doesn't have competition pressure that they need to be better? And I think it's politics. You've got to put pressure on the politicians to do stuff. Anyway, there was another question over here.
It's actually not a question, just a comment on what was just said. You can't win the governmental company in the US unless you actually do agile directions.
Yeah. So the US government has changed. They are demanding agile. Right. Well, that's good to know. I think we're out of time for this talk. I think there's a 10-minute break now. Is that right? So thank you so much for having me here, and good day.
Excuse me, before everybody leaves,